We're in section 3-3. And if we look at Theorem 1, we find that given a characteristic equation that has all real roots distinct, if I could spell distinct, real roots along with real, R1, R2, up to Rn, then our answer to our differential equation is going to be C1e to the R1x plus C2e to the R2x plus all the way out to C and at e to the Rnx. And then by Theorem 2, we have repeated roots. So I have real roots, repeated roots, and we'll put an R-E, repeat, wow, P-E-A-T-E-D, R1 out to R1, and they're all the same, and we can just call them R, I suppose. Y of x is going to be C1e to the Rx plus C2x e to the Rx plus C3 x cubed e to the, that's an e to the Rx, and it just keeps on going that way. And by Theorem 3, we have complex roots. R is going to be alpha plus or minus beta I. That's a beta, doesn't look like a beta. And y of x is going to be in the form e to the alpha x c1 cosine beta x plus c2 sine beta x. And I need brackets, and I don't have room for them. Okay, well, that's okay. All right, we'll deal with that. Okay, so the only other thing we have to worry about is solving problems. So we'll look at problem number 2 first. And we find 2y double prime minus 3y prime is equal to 0. We have a characteristic equation. Maybe we ought to read what the instructions say. Find the general solution of the differential equation. Okay, so that's what we're doing. So the characteristic equation, 2r squared minus 3r is 0. We factor out an r. 2r minus 3 is 0. And we find r is equal to 0, or 3 over 2. And that being the case, y says x is going to equal c1 e to the 0x plus c2 e to the 3 over 2x. And of course I'm not going to write it that way. I'm going to write it c1 plus c2 e to the 3 over 2x. So that's the last time I put a 0 in there and write e to the 0x. I'm just going to write down the constant when I see that. And so we're done with that problem. I suppose we could check it. So we will check that problem. And y is equal to c1 plus c2 e to the 3 over 2x. Y prime is c2, 3 over 2, c2e to the 3 over 2x, and y double prime is 9 over 4, c2e to the 3 over 2x, and I want 2 of them, and minus 3 of this guy, and I want none of them, and when I get done I best have a 0. Okay, so I have a 0 already for the C1, so that's good. I've got minus 9 halves plus 9 halves giving me a 0, so those guys go away. And these guys already went away because they're multiplied by 0, and I check. Isn't that convenient? Number 4. 2y double prime minus 7y prime plus 3y is 0. Characteristic equation. M2. 2m squared. What are we using m for? I can use m, so I don't care. 2m squared minus 7m plus 3 is 0. I can factor that somehow. M minus 3, 2m minus 1 is 0. Yeah, that works. So my m's, this is the last time I'm using m. I don't know why I'm using m for. Because we're finding roots. 3 and 1/2. 3 and 1/2. And normally we write those in ascending order, so it'd be 1/2, 3, and so we'd write that. So we'd do that, and then we'd say y of x is equal to c1 e to the x over 2 plus c2 e to the 3x. And we'll check that by using the back of the book and say that that's right. Next problem, number 6. We have y double prime plus 5y prime plus 5y is 0. We have a characteristic equation. R squared minus 5r plus 5. Who put a minus sign there? I don't know. 0. And I see that that doesn't factor, so I'm not going to try to factor it. Quadratic formula says r is going to equal minus 5 plus or minus the square root of 5 squared minus 4 times 5 times 1, which is 20, divided by 2. Okay, so r is going to equal minus 5 plus or minus the square root of 5 divided by 2. Isn't that great? Okay, well, that's what it is. It is what it is. Final answer. Y of x is equal to c1 e to the minus 5 minus square root of 5 over 2 plus c2 e to the minus 5 plus square root of 5 over 2, and there has to be an x here and there has to be an x there. And we'll check that by back of book. And check back of book. Okay, next we do number 8. See a pattern here yet? Y double prime minus 6y prime plus 13y is 0. And for 8 I'm doing the same thing I'm doing for the other one, so there's no difference in my instructions. characteristic equation r squared minus 6r plus 13 is 0. I find that not factoring that. Now this is going to be, I think, the first time we're going to talk about this. There's a quadratic formula, and the quadratic formula says if I have ax squared plus bx plus c is equal to 0, then x is going to be minus b plus or minus the square root of b squared minus 4ac over 2a, right? But there's also a half quadratic formula that says if I have a squared plus 2bx plus c, if I'm in that form, then my x is going to be minus b plus or minus the square root of b squared minus ac divided by a. Now you can do the math and decide that works for you or not, but it's just one of those things that when you have an even number sitting in front of the r, you can use the half quadratic formula to find out what r is and get there sooner. So it's going to be minus b, and b in this case is a minus 3. So that's going to be a plus 3 plus or minus 3 squared, which is a 9. Actually, it's minus 3 squared, which is a 9. Minus 13 divided by 1. And so I've got 3 plus or minus 2i over 1. So I got 3 plus or minus 2i. Y sub x, final answer, is going to be e to the 3x c1 cosine 2x plus c2 sine 2x. And then we'll check that by back of book. And that was number 8, right? Okay, so next one we're going to do is number 18. Right? 18 has the same instruction. So y, fourth order differential minus 16, fourth derivative, is equal to 0. I have a characteristic equation r to the 4th minus 16 is 0. And I can factor that r plus 4, r squared plus 4, r squared minus 4 is 0, and I can figure that out, and that's going to be r squared plus 4 r plus 2 r minus 2 is 0. So my r's are going to be plus or minus 2 plus or minus 2i. Plus or minus 2i. Alright, so final answer for 18. Y of x is c1 e to the minus 2x plus c2 e to the 2x plus c3 cosine 2x plus c4 sine 2x. And we'll check that using the back of the book. Check back of book and move on. Okay, number 10. Now, number 10? Was that number 18? Okay, that was number 18. Okay, so we'll do number 10. Number 10 looks fun. Number 10, 5, the fourth derivative of y, plus 3, the third derivative of y is equal to 0. Characteristic equation, 5r to the fourth plus 3r cubed is 0. I can factor out an r cubed. 5r plus 3 is 0. So it looks like I have roots of 0, 0, 0, and minus 5 over 3. No, not minus 5 over 3, minus 3 over 5 are my roots. So y sub x becomes c1 plus c2x plus c3x squared, because I have repeated roots, plus 3, 4, c4e to the minus 3 over 5. Okay, does anybody believe that that is true? I don't know, probably you do. But in any event, we're going to check it. C1, C2x, C3x squared, c to the fourth, e to the minus 3 over 5. Y prime, C2 to C3x, 3 over 5, C4, e to the minus 3 over 5. Y double prime, 2c3 plus 9 over 25 e to the minus 3 over 5. And there's an x sitting there and an x sitting there, and I don't have them. And that is really bad. So I'll put them back in. Y triple prime, constant term goes away. Minus 30, minus 30, 27. Minus 27 divided by 125 e to the minus 3 over 5x, and y the fourth derivative, 81 divided by, is that 625? 625 e to the minus 3 over 5x. Okay, so that being the case, we want something. We want 3 of these guys, and we want 5 of those guys, and we want 0, 0, 0 of these guys. And when we get done, we want the whole thing to be equal to 0. Okay, so that guy goes away, that guy goes away, he goes away, he, boom, 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 boom. All those guys go away. We come back to the last one. I have minus 81 plus 81, 0, check. Okay, so that was problem number 10. Done out of order. I don't know why I was doing it out of order, but I was. Number 20. Okay, number 20. Now let's see now. Number 20 says, same rules, but there's a suggestion here. And the suggestion is that we use r squared plus r plus 1 squared as an expansion. I don't know if I like that suggestion or not, but we'll see. Okay, so we have y to the 4th, now y to the 4th derivative, 2, y to the 3rd derivative, 3y 2nd derivative, 7y prime plus y is equal to 0. I have a characteristic equation, which is r to the 4th plus 2r cubed plus 3r squared plus 2r plus 1 is equal to 0. And I have a suggestion that suggests that perhaps that thing up there is really r squared plus r plus 1, the quantity squared. And that's what the suggestion is. So now, do we think that's the case? So I've got r to the 4th, and I guess what we have to do is convince ourselves. Squared plus r plus 1, r squared plus r plus 1, and see if we actually think that that's the case. So I've got r to the 4th plus r cubed plus r squared plus r cubed plus r squared plus r squared plus r plus 1, and I have one of those and two of those and three of those and two of those. So yes, this checks, and the hint was a good hint. That's very nice. So I've got my characteristic equation is r squared plus r plus 1, the quantity squared, is equal to 0. And I find that I'm going to have to use the quadratic formula. R is equal to minus 1 plus or minus the square root of 1 squared, which is 1 minus 4 divided by 2. And I'm going to have minus 1 plus or minus the square root of 3i over 2. Okay, so my roots are going to be minus 1 plus or minus the square root of 3i over 2, and minus 1 plus or minus the square root of 3i over 2 repeated roots. Okay, so that's relatively interesting. And so y of x is going to be e to the minus 1/2 x c1 cosine square root of 3x plus c2 sine square root of 3x plus x e to the minus 1/2 x c3 cosine cube root of x plus c4 sine cube root of x, cube root of 3x. Okay, and we'll do a quick check in the back of the book and call that guy right, because that looks like a pain to try to check manually. Okay, now I'm looking at number 26. And number 26 says solve the initial value problem. Okay, so that's what I'm supposed to do, solve the initial value problem. Alright, so I got y triple prime plus 10y prime plus 25, that's a 25y, is equal to 0. I have y of 0 is 3, y of prime of 0 is 4, y double prime at 0 is 5. Oh, that's good, 3, 4, 5. Now, why do we always pick these things at y at 0? Why can't we pick them someplace else? Anybody have any idea about that? Well, it turns out that when we get to doing LaPlace transforms, we have to have the initial condition at 0 in order for it to work. So that's probably why we get them now. Okay, well, that being the case, we have a, oh, this is a prime, isn't it? Is that a prime? Yes, 25 prime. Okay, so we have a characteristic equation, r cubed plus 10r squared, boom, plus 25r is 0. We bring out an r squared plus 10r plus 25 is 0. We factor that r plus 5, r plus 5 is equal to 0. And we find that r can be 0, it can be minus 5, or it can be minus 5. So y of x is going to be c1 plus c2 e to the minus 5x plus c3x e to the minus 5x. Isn't that lovely? Now, in this particular problem, we have initial conditions, so we are going to have to find C1, C2, and C3. And that was really cool there. So first thing we'll do is look at y at 0 is 3, which is going to be C1 plus C2 plus nothing, because that's a 0. Alright, so just C1 plus C2. And then we'll look at the first derivative of our answer, and we see that that's minus 5c2 e to the minus 5 plus c3 e to the minus 5x, there's an x there too, minus 5c3x e to the minus 5x. And we look at the first derivative at 0, and we remember that it is 4. And we say, well, okay, it's 4, so that's going to equal minus 5c2 plus c3. Okay, and there's an x sitting right here, so that term goes away. So that's good. We have two equations, three unknowns, so we need another equation. Y double prime of x is equal to 25 c2 e to the minus 5x minus 5 c3 e to the minus 5x minus another 5 c3 e to the minus 5x plus 25 c3x e to the minus 5x. Okay, and we find that y double prime at 0, we remember that it's a 5, and that's going to be equal to 25c2 minus 10c3. Okay, so now we remember that we have three equations, three unknowns. C1 plus C2 is equal to 3 minus, well, we're going to line these up better than that, is equal to 3. And we have minus 5C2 plus C3 is equal to 4. And we have 25C2 minus 10c3 is equal to 5. And those are the three equations, three unknowns. Now, normally what you'd probably do is just put them in your calculator and tell you what they are, but we're going to use Kramer's rule. So 3, 4, 5, 1 minus 5, 25, 0, what is that, 1? 1, 0, 1, minus 10 on the top, and on the bottom 1 0 0, 1 minus 5 25, 0 1 minus 10. Then we have more zeros on the top than on the bottom, so we'll do the bottom guy first. I see a 50, I see a minus 25 for a 25 on the bottom. On the top I see 150, I see another 5, minus, I see a 0, I see a 75, and I see a minus 40. So I see 120 over 25 120 over 25, which is a 5. It is. It is? Okay. Which is a 5. C1 is 5. Alright, well C1 is 5, then C2 had better be minus 2, and C3 had better be what? C3 minus 2 for that guy, so that's minus 50, it goes over there, and that's 45 is 4.5. And, well, I don't know about that. Y of x is going to be C1, which is 5, minus 2 e to the minus 5x plus 4.5 x e to the minus 5x. Well, I'm looking in the back of my book real quick to see whether or not my author agrees with me, because I'm thinking that that doesn't look right. But you can't really tell with differential equations looking right and wrong. It's an interesting idea. Okay, so we're in 3, and we're doing number 26. And yeah, that's not the right answer, the 26. So now the issue is, what in the world did I do wrong? Where did I go wrong? And all of you out there already know where I went wrong, so. Okay. 3, 4, 5, 1 minus 5, 25, 0, 1 minus 10. 1, 0, 0, 1 minus 5, 25, 0, 1, blah, blah, blah. 50 minus 25, give me a 25. 150 plus 5, 0, 75, minus 40. Grab my calculator real quick. 1, 5, 1, 5, okay. 1, 5, 0 plus 5 minus 75 plus 40. 120. 120 over 25 is 5. No, it's not. No, it's not. Oh, gee, how could I possibly do that? Divided by 25 is 4.8. Okay, so this guy is 4.8. And if he's 4.8, then C2 has to be minus 1.8 minus 1.8, and a C2 is minus 1.8. 25 times 1.8, turn it into a minus, because I'm putting on the other side, minus another 5 equals, divided by 10, equals 5. So C3 is equal to 5. Okay, so y of x, cross out this guy, 4.8 minus 1.8 e to the minus 5x plus 5x e to the 5x. We'll go look in the back of the book again and see if we're anywhere nearer the answer than we were last time. And then 3 number 26. Okay. 24 over 5. Is that 4.8? Yes, it is. 9 over 5. Is that 1.8? Yes, it is. And 25 divided by 5. Is that 5? Yes, it is, except it's minus 5. So the answer to the book puts a minus sign right there. That's very interesting, isn't it? How did they get a minus sign right there? Okay, so I've got minus 1.8 minus 1.8 goes over there and is positive. I divide by 10. It's going to be a negative number. So the minus is correct. So final answer, y of x 4.8 minus 1.8 e to the minus 5x minus 5x e to the minus 5x. Put an x there. Well, that was cool. Let's see if 30 is any better. Number 30. Y to the fourth derivative. The fourth derivative of y minus the third derivative of y plus the second derivative of y minus 3, the first derivative of y minus 6y is equal to 0. Characteristic equation, r to the fourth minus r cubed plus r squared minus 3r minus 6 is 0. Now problem number 30 has an instruction that says find a small integral root of the characteristic equation by inspection, then factor by division. Okay, so if I was going to be an integral root, what would I be? So we'll try r is equal to 1. 1 minus 1 goes away, 1 there, 1, no, not that one. We'll try minus 1. Minus 1 becomes a 1, that becomes a 2, that becomes a 3, that becomes a 6, minus 6, boom. So minus 1 works. The factor is r plus 1. Okay, so we're going to take r plus 1, divide it into r to the fourth, r cubed, r squared, 3r minus 6. I'm going to get r cubed, r to the fourth plus r cubed minus 2r cubed plus r squared minus 2r cubed. Get minus 2r cubed minus 2r squared. I'm going to get 3r squared plus 3r plus 3r squared plus 3r gives me 0. There's a minus sign missing. Where did my minus? There. See that minus sign right there? I see it right here. Minus. There. That's better. Okay, so this guy here is minus, so that's better. So now I got minus 6r minus 6 minus 6 is equal to, oh, I don't have to put an equal to 0 up there. But now I've factored it, and I got a new equation. and it's a new characteristic equation. R cubed minus 2R cubed, that's a square. That's the problem with not having people in the classroom telling me when I do things wrong, but that's okay. We can handle it. Squared plus 3R minus 6 is 0. And what I would do with something like that is put it in my calculator and let my calculator tell me what the answer is. So when I do that, I get my R's are going to be the minus 1 I found before, a 2, and a plus and minus the square root of 3. Now that seems kind of weird, but that's what it is. Y of x is equal to c1 e to the minus x plus c2 e to the 2x plus c3 e to the minus square root of 3x plus c4 e to the plus square root of 3x. And this checks by back of book. And we'll move on. Number 34. We have 3 third derivative of y minus 2 second derivative of y plus 12 first derivative of y minus 8 y is equal to 0. We have a characteristic equation. 3r cubed minus 2r squared plus 12r minus 8 is 0. Isn't that nice? So, what are we going to do about that? Well, I think what we're going to do is, seeing that this is a third order guy here, we'll just put it in our calculator and have it tell us what the roots are. And when we do that, we find the roots are 2 over 3 and plus or minus 2i. Boy, that sure is a lousy plus or minus sign, isn't it? We'll try it again. Plus or minus 2i. And y sub x is going to be c1 e to the 2 over 3x plus c2 cosine 2x plus c3 sine 2x, and that checks by back of book. Check back of book. Okay, we're going to do, we have 2 more to do. We have 2 more to do, and then the video is going to be over. Number 38. We have y. Why am I doing this in green? Y double prime. No. Y the third derivative. 38. Yeah, y the third derivative. Minus 5y the second derivative plus 100 y prime minus 500 y is 0, and we have y at 0 is 0, y prime at 0 is 10, y double prime at 0 is 250. Okay, so that's what we're doing. Characteristic equation, r squared cubed r cubed minus 5r squared plus 100 r plus minus 500 is equal to 0. Again, this is a third order thing, so we're just going to put it in our calculator and say that r is what? R is going to be 5 and plus and minus 10i. So y of x is going to look like c1 e to the 5x plus C2 e to the, no e, get rid of the e, C2 cosine 10x plus C2 sine 10x. Okay, so that's good. And y at 0, y at 0 is going to be 0, which is going to be C1 plus C2. And y prime at x, now we have to solve for C1, C2, and C3. Oh, look at that, that's not a 3. Yeah, that's better. 5 C1 e to the 5x minus 10 C2 sine 10x plus 10 C3 cosine 10x. Y prime at 0. Y prime at 0 is supposed to be 10, which is going to be 5 C1 plus 10 C3. Okay, we're looking at y double prime at x. We have 25 C1 e to the 5x. We have minus 100 C2 cosine 10x. We have minus 100 C3 sine 10x. And y double prime at 0 is 250, which is going to be equal to 25 C1 minus 100 C2. Sine at 0, 0 goes away. Okay, so I have three equations, three unknowns. C1 plus C2 is 0. 5 C1, 10 C3 is equal to 10. 25 C1 minus 100 C2 is equal to 250. Okay, so C1 using Kramer's rule, 0, 10, 20, 250. 250, 1, 0, minus 100, 0, 10, 0. And on the top I have 1, 5, 25, 1, 0, minus 100, 0, 10, 0. Okay, so I see 0, I see 250, no, I see 2,500, I see another 0. On the bottom, I see a 0, I see a 250, I see a 0, and then I see a minus, nothing, minus 1,000. Okay, so that looks like 2,500 divided by 1,250, which is 2. Okay, so if C1 is 2, C2 is minus 2, so it can be 0. And C3 will be 0 because 2 times 5 is 10, and I got 10 over there, so C3 has to be 0. Okay, so final answer, y of x is equal to 2 e to the 5x minus 2 cosine 10x. And we're going to check that, so y prime is 10 e to the 5x minus plus 10 sine 10x. And we're going to look at y at 0. Y at 0 is supposed to be 0. It is 0. Checks. Okay, so y prime at 0 is supposed to be 10, and that checks. Y double prime is equal to 50 e to the 5x plus 100 cosine x, and y double prime at 0 is supposed to be 250, and I have 150, so what did I do wrong? See that 2? That makes that a 20. That makes this a 200. That makes this a 250. Check. Okay, now I'm supposed to get 0 when I take minus 500 of the first guy, 100 of the second guy, 5 minus 5 of that guy, and 1 of that guy. And I'm supposed to get 0. Isn't that nice? Now how am I going to do that? Oh, well, I didn't calculate the third derivative yet. Okay, so I'm not ready to do that yet. Okay, and when I do, I'm going to have to do something about being able to see everything. Y triple prime 250 e to the 5x. There's a 10 sitting there. Minus 2,000 sine 10x. And when I add all things together, I'm supposed to get 0. Well, I'm going to go in the back of the book. I do. The back of the book checks this problem, so I got it right. And that'll save me from doing all those weird things. Okay, one more. Number 46. Okay, so I have y double prime minus iy prime plus 6y is equal to 0. And there will be a problem exactly like this, only completely different, on your test. So if you made it to the end of this video and you're looking at this problem, that'll be a good thing. Okay, so I have a characteristic equation, r squared minus ir plus 6 is 0, and I can factor that. Minus 3i, 2i, that gives me a plus 6, and that gives me a minus 3. Okay, so that's good. So my r's are going to be solution set minus 2i, 3i. Maybe I should make my brackets a little better, but that's what it is. Y of x is equal to c1 e to the minus 2ix plus c2 e to the 3ix, and it checks by back of book, but I will go and I will check it anyway, just to show you how. So I got y is equal to c1 e to the 2ix, that's a minus sign, plus c2 e to the 3ix, y prime minus 2i c1 e to the minus 2ix plus 3i c2 e to the 3ix, y double prime. Okay, minus go away, positive I becomes minus, minus 4 c2 e to the minus 2ix minus 9i, no minus I, no I, minus 9 C2 e to the 3ix. Okay, now when we add these guys together, we're supposed to get 0. Okay, so I want 1 of him minus I of that one and 6 of this one. Okay, so I got minus 4. I got a minus 2 for a minus 6, because minus and minus is positive, I times I is negative. So those guys go away. Boom, boom, boom. I got 9. I got a plus. I got a minus 9. I got a minus. Oh, I got a plus 3. I got a plus 3, a plus 6, a minus 9. That term goes away. 0 is equal to 0, and it checks. But we said the back of the book checked anyway. So that is all I'm doing for this particular section.